The emission spectrum of atomic hydrogen can be obtained in the following experiment. Take a glass tube filled with hydrogen gas and apply a voltage to it. The hydrogen molecules will atomize, giving excited hydrogen atoms that relax to the ground state via the emission of photons. Next, pass those photons through a slit, and then through an analyzer, like a prism or a grating. On a detector, you will see a series of discrete wavelengths light up, and not a broad black body emission spectrum, as would be expected from the whitish appearance of the light. Let's plot the wavelength series. Here's the lambda wavelength axis, and here's the wave number axis. The series starts with a line at 656.5 nanometers. The next line is at 486.3. More lines follow in ever closer spacing, and they converge to a series limit at 364.7 nanometers. In terms of wave numbers, the series is located between 15,200 and 27,400 inverse centimeters. In terms of electron volts, it lies between 1.90 and about 3.40 electron volts. This series is called the Balmer series, after the Swiss scientist who first figured out a systematic relationship between the various line positions. He plotted the wave numbers of the various lines against 1 over n squared, where n is an integer. The various lines gave points that all lay on a straight line. N was 3 for the first point, 4 for the second, and 5 for the sixth, and so on. This was very surprising. Other series were observed. There was the Balmer series in the visible range, and then there was the Lyman series in the UV range. The first series in the infrared was the Paschen series. All these series of emission lines can be modeled with a single formula, the Rydberg formula. Which states that the wave number of a line depends on two integers, and it is given by RH times 1 over n1 squared minus 1 over n2 squared. RH is the Rydberg constant for hydrogen. And its value is about 109,677 inverse centimeters. N1 and N2 are integers that specify the line. For the Lyman series, N1 equals 1, and N2 equals 2, 3, 4, and so on. For the Balmer series, N1 equals 2, and N2 starts at 3. For the Paschen series, N1 equals 3, and of course N2 starts at 4, 5, and so on.